So in the last video we configured ADS to connect to Watson ML, and we'd got to this point here where we'd selected the this P3 algorithm. We can see we've got a number of steps here. The first step up here is to select the provider and the ML deployment. Then we define the input schema, test it, and then define the output schema. So we'll go through these steps now. So again, just selected this P3 model, and I'll click next, and you can see it's retrieved the metadata for this from the actual ML model. We've got age, gender, BP and BMI. These are exactly the attributes that the model is using to predict the drug type. So I click next. Now, to help us generate the input and output schema, we can test it here. So if we provide some characteristics of a patient, so 55, male, their blood pressure is low, and their BMI is 30, for example, click run. That will send the data into the predictive model, and we will see the output here, and ADS will be able to use this to build the input and output parameters. Sometimes this can time out the first time the model is invoked, so if you do get an error, just try it again. Okay, so we can see it's recommending drug E with a very high probability. So the next step is to generate the output schema. We can do this manually, or we can generate it from the test output that we had previously. And we'll let ADS do that. So now we can see we've got a prediction coming back, which is a string. This will be for the drug type, and the probability that, or rather the confidence of the algorithm. So that's done. So now I'll click on create. So now we have the skeleton for the predictive model, which we can use to map our rule data to the ML model itself. Okay, so it would be quite reasonable to define a number of different inputs here at the bottom here. So we can have age, BMI, blood pressure, gender, and have those coming in as primitive data types, and ADS going through the logic, doing the mapping, calling the model, and then outputting the drug type as a single value up here. But that's a bit limited. So what I'm going to do is, before I start doing the mapping into ML from ADS, I'm going to create a couple of data types. So one will represent the patient data as a composite, and one will represent the ML model also as a composite. This is quite simple. So back in the project, I'm just going to go over into data models. I haven't got one, so I'm going to create a data model, and I'll call it drug model. And in this data model, I'm going to have two types. So the first one will be patient data. So I'm going to define this new type here. So it's patient data, and I'm going to add the various attributes for patient data here. So we're going to want age, which is an integer. BMI, which will be a number. Blood pressure, which will be a string. And finally, gender, which will also be a string. Okay, so that's patient data, gender, BP, BMI, and age. Going to create another composite type to represent the result of the predictive model. So let's call this one predictive model result. And the attributes of this will be, I guess, the prediction itself, which is a string prediction, and we'll have the probability as well. This is a number type. Okay, so there are two composite types to represent the data that's going to go into the model from rules, and also the result that we're going to get back out of the model that comes back into rules for reasoning. Okay, so let's get back into the predictive model. This diagram is describing the way in which the model is used and how it's integrated with rules. So we can see that the bottom layer we have the input data that's coming in, we have a decision node that does mapping from these input types into the data structure that's used by the ML model, and then we have another node which is a placeholder for any kind of output mapping that we want to do. And we're going to use the new data types that we've created to make this a little bit clearer. So I'm going to delete this input node, and this one at the bottom, I'm going to change the name of this. So this will become patient details, and the output type of this node will be the patient data custom type that we created. But notice we've also got the two ML model types that were generated automatically when we brought the model into ADS. So we've got an input, set of input parameters, set of output parameters. So essentially what we're doing is we're mapping patient data to the input parameters of the ML model, and we're mapping the ML model output to this predictive model result. And that's all we're doing here. So patient details, this will be patient data type. Now into the input mapping, this decision node is called input mapping, but its output is type ML model input, and that's what's expected by this node. So in the logic for this, I'm going to create a mapping rule. And this will provide me with the placeholders to map rule parameters into the ML parameters. So we've got a placeholder for the age, the BMI, the BP, and the gender. And if I click on age, we can see I don't actually have a placeholder or a value for age. There must be a typo in the data model. But for BMI, we can see we've got the BMI of the patient data. So let me just correct that first. So I go out of here, come back up to the model. There must be a typo in the data model for age. Yeah, and it's a string. It should be an integer. Okay. So back into the model once more. Okay, so I should be able to fill in these placeholders now. So age will be the age out of a patient data, well, the patient details as the variable is called. BMI will be the BMI out of a patient data. Again, the variable is also called patient details. Similarly with BP. And finally, gender. Okay, so that's the mapping rule completed. Okay, the next decision node, this ML model invocation, we don't need to do anything with that. This was generated for us. It's expecting an ML model input. That's exactly what we're giving it, and what comes out of this is an ML model output type. So this is going to flow into this final node up here, and this is where we're going to do the mapping back into rules. So what I'll do is I'll change the output type of this node from a string to the predictive model result, and I will create a rule for that and do the mapping. So I'll map output, and so the decision will be a new predictive model result, because that's what we specified as the output type, and we've now got placeholders for the probability and the prediction. So the probability is going to come from this predictive model result here, and similarly the prediction. Okay, so that's done. So just to recap, we're sending in an object of type patient details, and we call that patient data in the rules. We do the input mapping from that to the ML input, the model's invoked, and then we've got another final rule that maps the ML model output into our predictive model result. So we can give that a test now. I can click on the validation button, and I'm going to create a test set. Let's call this one, this will just be a basic smoke test to see if it's working, and we can see that it's asking us to provide the patient details, this value that comes into the bottom. So let's go for age 55, BMI of 22, blood pressure, let's make this one high, and this will be female. F. I click on run, and after a few seconds we'll get our result. So here we are, we've got a prediction of E, and the confidence is 0.99, and we can see how the various data has propagated through the model. Okay, so that's done. Okay, so we can add another data set here. Let's give this some very different parameters. 76, let's say BMI is 40, BP is medium, and this is a male. And click run, and we've got a prediction of C. Again, very high confidence. Okay, so that kind of wraps up this video. We've created a data model to accept the values from the Watson ML models, and we've integrated these into ADS, and I guess the next step is to actually integrate this predictive model into a regular decision service.